So let's get started. Now, before I start working with matrices in very much detail, I want to start with a little bit of motivation for this. And to do that, we're going to look at something that should be a bit familiar, where we want to solve the system of linear equations we have here. It's only two equations with two unknowns, so it's pretty straightforward. In this case, we should be able to tell pretty much on sight that one good way to approach this problem is by adding the two of them up. That is, you can think of adding the second equation to the first one, and in that way, the y values would cancel out. You'd get 7x's and 14 constants on the other side of the equality, excuse me. But you get those values, divide by 7, and you get that x is equal to 2. Plug your values back in, you'd get y is equal to 0. Elimination's pretty easy there, and if you don't like elimination, looking at these values, you could probably get away with a substitution. It'd take a little bit more algebra than people usually like for substitution, but it could be done. Or, because both values are pretty small and one of them's 0, people like guessing 0, you just guess and check your way to that, and it wouldn't be that hard either. So, here, algebra's algebra, we don't need anything special, right? We can pretty easily get that our solution in this case is the coordinate, if you want to think about it that way, 2, 0. But that's not very interesting, is it? So let's think about doing something a bit more interesting. Let's think about something that has a little bit more going on, a system more like this here, where now we have three equations and three unknowns. 4x plus 4y minus 8z equals 0. 2x plus y plus 3z equals 6. Negative 2x plus 4y minus 5z equals negative 3. And sure, you could probably guess and check your way there. Hint, the answer is actually just 1, 1, 1. It's not very easy to get there, but it's an easy answer. Although, if you can do this one without a whole lot of work, congratulations, you're probably better at this stuff than I am. But the point is, looking at it, guessing and checking, not the best way to handle that much work. And for that matter, if you wanted to think about this in terms of substitution, substituting your way around three variables takes a lot of work, and then eliminating with a system of three things, it can still be done, but it requires a lot more care than people generally want to do, at least directly. The point is, this thing, yeah, we can do it with the methods that we have, but truth be told, trying to handle it that way is probably not particularly efficient, or for that matter, particularly easy. So let's just keep this one in the back of our mind for a second and drop back to the one we saw before. That other system of equation, the easy one, as it were. And let's look at that easy system and recognize that when we're trying to solve it, when we're trying to find the values x and y, those letters, those variables, those placeholders, they're not actually that important to the math that we're trying to do. Looking at it, we don't particularly care about x and y as we're trying to find their values, which is kind of paradoxical, but it makes sense if you think about it. And instead, really all we care about are the coefficients on x and y, along with the constant that they're supposed to equal to. Because that's what really determines what happens with those values. We're trying to make things fit that picture, that scenario there. And while we're trying to make things fit, what we're trying to fit isn't as important. So we can really focus down entirely onto those values, the 4, the 2, the 8, the 3, the 2, and, negative 2, to be specific, and the 6. And we can kind of pull those out. Just ignore the other stuff. It doesn't really matter. And focus on the numbers. And if we do that, we pull those numbers out, we get over to something like that, we make a construction that's called an augmented matrix. And that's what we're going to be looking at today, is how we can handle things of that nature to deal with things of that nature.